In this video, we'll illustrate Francisella tularensis, which causes tularemia. The drawing is going to be about a little rabbit named Francis. Like our other zoonotics, Francisella will be a quick one to cover, so let's get to it. We decided to base this scene around a rabbit because rabbits are the main reservoir for Francisella. Humans get the disease either from direct contact with rabbits, like handling rabbits or eating rabbit meat, but much more commonly from indirect contact, through a tick vector. So to add these ticks, we'll have Francis scratching some pesky ticks off of him. As a side note, these ticks are not the same as the ticks that cause Lyme disease. Those were the Ixodes tick. Instead, they're the dermacenter tick. If we do have something spread by the Ixodes tick, we'll be sure to make it very clear. And there is one final note about transmission for Francisella. It can be aerosolized, so it could potentially be used in bioterrorism. So if you do have a case of tularemia, it's mandatory that you report it to the CDC. So part of the story is Francis is a fiend for radishes. He loves them, so let's draw him in a radish patch. The reason we've made Francis love radishes is because Francisella appears a lot like a radish. It's red for gram-negative, and radishes are neither perfectly spherical or bacillary. They're kind of somewhere in between, and we describe bacteria with the shape as coccobacilli. So these radishes tell you that Francisella is a gram-negative coccobacilli. Now we're drawing Francis's cage. Notice how his cage door is open? That's because Francisella is facultative intracellular, which is important to know because this means that recovery from infection depends on cell-mediated immunity. It also helps facilitate Francisella's spread from one side of the infection to the rest of the body. So let's go over this process of spread now in more detail. As I mentioned earlier, the most common way Francisella gets transmitted to humans is via tick bite. The bacteria enters at the site of the bite and causes a painful ulcer, which we're representing with this rabbit hole that's ulcerating into the soil. So Francis takes all of these radishes he finds and runs them into his hole, which has an elaborate underground tunnel system in which he stores the radishes. He has so many, he doesn't know what to do with them, and they're beginning to rot. Notice the center of the radish pile is rotting? This story is demonstrating the spread of Francisella. It enters through the rabbit hole, the ulcer at the site of the infection, goes into macrophages, and travels through the lymph system, which is represented by the tunnel system, to reticuloendothelial organs like lymph nodes, and causes granulomas with caseating necrosis, which we've represented by this collection of radishes which are rotting in the center. Notice how the granuloma is pushing up the dirt above it? Well, same thing happens to lymph nodes, which swells and causes palpable mounds. So we'll draw some more of these dirt mounds to represent the regional lymphadenopathy caused by tularensis. And from here, it can spread systemically to other lymph nodes. So to treat tularemia, the drug of choice is streptomycin, an aminoglycoside. We have a recurring symbol for aminoglycosides. It's the weapon that Raphael uses in the Ninja Turtles, the Psy. And I believe that's the second Ninja Turtle reference I've used. I'm not sure why. I'm really not that into Ninja Turtles. But anyway, some gardening tools look similar to Psys. So we'll add these gardening tools, and this one looks particularly like a Psy for aminoglycosides. And that's it. That's the high yield facts we need to know for Francisella.